Super excited to be here today with Dr. Will Bulsiewicz. Did I say your name right properly, Dr. Will?
You had an excessive amount of emphasis on the bull. It was like, you could just kind of make it a little bit more even keeled, like Bulsiewicz. But
Bulsiewicz.
yeah, no, you sounded almost Romanian and like you had something in your mouth when you said it. but that's okay.
Okay.
It's great to see you, my friend.
Awesome. So today we have with us Dr. Will Bulsiewicz. He is a graduate of Georgetown University School of Medicine. He's a respected clinician and has published more than 20 articles in peer-reviewed scientific journals, including repeatedly publishing in the top American gastroenterology journals, Gastroenterology, the American Journal of Gastroenterology, Clinical Gastroenterology, and Hepatology, and Gastrointestinal Endoscopy. Now, Dr. B has quickly become one of the internet's most trusted sources for gut health. He's been featured in numerous national magazines, including Men's Health, Women's Health, and Reader's Digest, and has been profiled by The Post and Courier and Vanderbilt magazine as well. He regularly gives lectures on gut health and has some of the most fantastic podcasts that we've ever listened to. So we wanted to get Dr. B here today to talk about some very complex digestive physiology, which seems to be present across many forms of diabetes. And he has an absolute mastery of the subject. So Dr. B, thank you so much for being here with us today.
Thanks, guys. It's a pleasure to be here, as always.
Cyrus, in addition to his epic podcast, I think his performance on the recent Mastering Diabetes webinar was one of his best. So we're really happy to have you back.
No question.
Thank you, Robbie. Appreciate it. Yeah, no, it was fun. We had a great time, and I can't wait to do it again. And my favorite part were the live call-ins. That's what I loved the most.
Okay. Well, unfortunately, we can't do the live call-ins on this one, but we're going to talk about some of the same topics that we talked about in the previous webinar, but we're also going to go into more detail here about the specific microbiome diabetes connection, because it's very strong and it's real deep. Now, Dr. Will, you're known as the Gut Health MD. Can you tell us a little bit about your personal story about how you got into this field of gastroenterology in the first place, and how did plant-based nutrition make its way into your life?
Gosh, so that story, the movement into gastroenterology for me comes way before any sort of recognition of the gut microbiome, and also way before any sort of transition towards a plant-based diet for me. So this goes all the way back to 2005, my third year of medical school. And I was just kind of searching for something where I could combine something that used my mind, allowed me to sort of pick apart complex problems with my brain, and also use my hands. I really loved playing video games as a kid. And so, don't give me World of Warcraft. If you do, I will end up divorced and my kids will hate me. So I've never actually really played that game. But anyway.
Good to know.
I'm worried about what would happen if I ever did. I think that's my point. And so with that sort of idea framework in mind, I found gastroenterology and was very excited about it because it's a blend of the two. I spend about half my time doing procedures, colonoscopies, upper endoscopies, preventing colon cancer. I do a lot of things that are very satisfying because I'm helping people. And at the same time, I spend half my time in the clinic talking to people who have complex digestive issues, heartburn, trouble swallowing, abdominal pain, nausea, vomiting, diarrhea, constipation, liver disease, any of those things, gastroparesis causing nausea and vomiting. And so I take care of all these different issues. And I love what I do. I really enjoy what I do. So all those decisions were made back in 2005. I spent years, it's very hard to get into gastroenterology these days. So I spent a significant amount of time just basically building up the resume necessary for me to be able to do that. And the bottom line is that I finished my training in 2014, entered into clinical practice, and patients were asking me, "Doc, what should I eat?" And as a medical doctor, I care deeply about my patients. I care deeply about having the correct answer to these questions. And so I would spend my nights going home and trying to answer these questions and figure it out and dig into the research. And, the beauty of having a background in clinical research, publishing papers and masters of clinical investigation and all those things, is I don't need someone else to explain this to me. I can like dig into the research and find the answers myself. That's what I was trained to do. And so I went, and as I dug into this research, saw the power of plant-based nutrition. And I saw it in my own life too, personally, because I had the worst diet on the planet. Like I was a junk food junkie, and met my wife, and my wife ate completely radically different than me. And, you know, I was just like in the beginning, oh my gosh, what is she doing? She's getting a plant plate. And I'm, you know, how could you give up like the opportunity to get something like a steak or something like that? And over time, I started to make small changes. I felt better. And ultimately that just grew and grew and snowballed and more momentum until I got to the point where here I am, and I've been plant-based and feel great, never felt better.
All right, Dr. B, the topic of the microbiome, gut health, is simply blowing up on the internet. It's everywhere. And it seems that people are beginning to understand the importance of having optimal gut health and hence watching what they eat. So what exactly is the microbiome, and how does one's microbiome health affect their chronic disease risk?
Sure. To summarize as efficiently as I can, Robbie, the microbiome is a community of microorganisms, 39 trillion microorganisms, more than there are human cells in your body. In fact, if you were to count up the cells in your body that actually have a nucleus and the different organelles that we learned about in biology in high school, you would have basically 10 times more bacterial and microbial cells than you do actual human cells in your body. And so this community of microorganisms, they're not just kind of passively there along for the ride. They actually have taken up residence as a part of us. There's never been a moment in human history, in our evolutionary history, that they were not a part of the human story. They've been with us through the good times, through the bad times. They've helped us to survive, and they have taken up a role in our body that is actually critical to human health. And it goes far beyond digestion, which they are very, very important for. They are like, you are literally incapable of processing fiber without them. You cannot do anything with fiber without your microbes. But with your microbes, you can take fiber and transform it into the most amazing postbiotics, which we can talk about in more detail in a few moments. But it goes beyond just digestion. It actually connects to our immune system. 70% of our immune system lives within our gut. It connects to our metabolism, our hormonal balance, insulin included within that package, satiety hormones included within that package, but even, hormones that make us more masculine or more feminine, estrogen, testosterone. It connects to our genetics. 99% of our genetic code is actually of microbial origin. If you were to look at your gene pool, you are 1% human and 99% microbial when it comes to your genes. 1% human.
So back up here, if you don't mind me cutting you off here for a second. You said from a cellular perspective, we are 10% human, meaning that 90% of the cellular population of a human being is bacterial and 10% are cells that contain a nucleus. But when it comes from a DNA perspective, or from a genetic perspective, we are 1% human and 99% bacterial. Is that right?
Or even less than 1% human, actually. It's more like 0.5% to be a little more precise, because I know that you appreciate precision, Cyrus.
That is fascinating. Honestly, I mean, there's many things about human health which fascinate me, but that fact unto itself blows my mind.
Right, and they have the ability to regulate our genetic expression as well, right? So there's a reason why you are not personally pre-programmed to develop certain disease. We can't just look at your genetic code and know what's going to happen to you during your lifetime. That's not the way that it works. There's other influences that determine what you will actually develop from a health and disease perspective. And our microbiome has a lot to say with the way that this plays out, the way that this story plays out, which makes a lot of sense, because basically the imprint of your microbiome, your microbiome is as unique as your fingerprint. There is literally no one on the planet who has a microbiome exactly like you. And your microbiome is essentially a reflection of your lifestyle, predominantly the food that you eat, but so much more than that. Your exercise, your sleep, the amount of stress that you carry, the time that you spend socializing with other people, surrounding yourself with other people. All these different things have an influence on your microbial makeup, and then that microbial makeup has a powerful effect on health throughout the entire body.
Is it true to say that the food people eat has the biggest impact on their microbiome health?
100%. That's an easy answer. 100%. Look at that cat. That was really cool. The food that you eat is the number one determinant. And here's the reason why, Robbie. Most of your microbiome is in your colon. The vast majority of your microbiome. You do have a skin microbiome. You have a microbiome in your mouth. There is a minor amount of microbiome living in your stomach, living in your small intestine, minor amount. The majority is in your colon. Women also have a vaginal microbiome. And so what passes through the colon? The food that you eat on a daily basis. And the average person in the United States eats about 3 pounds of food per day, 1,000 pounds of food per year. If you live an average life expectancy, that's 80,000 pounds of food during your lifetime. And that is ultimately what determines the makeup of your microbiome. And we have studies that show us that literally with a dietary change, in less than 24 hours, there can be radical changes to your microbiome as a result of changing your diet.
Wow. Okay. So which foods actually promote the best gut health possible?
Well, I think to answer that question, let's just cut straight to what I would classify as one of the most important microbiome studies to date. This is not cherry picking. This is literally one of the most important microbiome studies to date. It comes from Nature, which is the journal, the top scientific journal, literally on the entire planet. If we cure cancer tomorrow, this is where we're going to publish it. The year was 2014. The lead author was Lawrence David. And Peter Turnbaugh, who's a very prominent, well-respected microbiome researcher, was also one of the authors of this paper. And basically what they did is they took a group of people and they put them on a completely 100% plant-based diet for 5 days, tracked their microbiome day by day by day, and then they flipped them over and they went over to a completely animal product-based diet. You can call it the carnivore diet. Like literally, that's what it was. It was meat, eggs, and dairy. That's it. And so they ate that completely animal-based diet. And again, tracked their microbiome day by day by day by day. And what they noticed were profound changes in the microbiome in literally less than 24 hours after making these dietary changes. And when you eat the plant-based diet, what you see is the emergence of very healthy anti-inflammatory bacteria that actually are very skilled at helping us to unpack fiber and to release the health promoting benefits of our fiber in the form of something that is called short chain fatty acids. Short chain fatty acids are produced when healthy microbes basically consume dietary fiber and release acetate, propionate, butyrate. Those are 3 examples of short chain fatty acids that will be released from dietary fiber. So in this study, when you were on the plant-based diet, you got more Eubacterium, more Roseburia. These are specific types of microbes that are known to produce short chain fatty acids. And guess what? There are studies, let's just get right into type 2 diabetes with this. There are studies that show us, in fact, there was one that just came out, published in Nature, that showed us that the gut microbiome is actually causative in type 2 diabetes. That is not just changed as a result of type 2 diabetes, that it actually is a critical part of the pathogenesis of the condition. And in that study, what they found that was critical were these specific bacteria that, by the way, were found back in 2014 in this Nature article. Eubacterium, Roseburia, which produce short-chain fatty acids. In this most recent study that came out, they found diminished levels of those specific types of bacteria, which lead to lower levels of short-chain fatty acids. So when they did this study back in 2014, basically what you see is that a plant-based diet is anti-inflammatory, health promoting. And then when they flipped them over to the animal-based diet, just to cut to the chase real quick, you don't see eubacterium, you don't see roseburia. Instead, what you see is the emergence of inflammatory microbes, some of which, one specific one called Bilophila wadsworthia, has been clearly associated with the development of inflammatory bowel disease. So literally in less than 5 days, you see emergence of inflammatory microbes on an animal-based diet. And you see essentially the constructs or the foundation of inflammatory bowel disease being laid. You're not going to develop it in 5 days on this diet. But if you have the right genetic milieu, the right genetic profile, you have set the stage for the development of inflammatory bowel disease with that diet.
Okay. This is exactly where I want to go with this conversation, because an altered gut microbiome is causative in the pathogenesis of type 2 diabetes, like you just explained. It's also implicated in type 1 diabetes, as we've talked about previously. So the question for you is, could you go into a little bit of detail here about what changes are happening other than just changing the population of bacteria inside the microbiome that plays a role in the development of type 2 as well as type 1? Is it increased intestinal permeability, bacterial endotoxins? You're a master of all this stuff, so you go into detail and tell us exactly how the pathogenesis of type 2 versus type 1 differs from a gut perspective.
Sure. So first of all, I would imagine that most of your listeners already know this, but just in case, type 1 diabetes is sometimes called juvenile diabetes, and it's autoimmune. It's autoimmune type diabetes in the sense that you basically are destroying the islet cells which produce insulin in the pancreas, as opposed to type 2 diabetes, which is not the destruction of the cells that produce insulin. It is instead the resistance that comes from well, I mean, I guess we'll talk about the microbiome, but the bottom line is it's the development of insulin resistance, which basically requires your body and your pancreas to pump out more and more and more and more insulin. And eventually you get to a point where your body is literally incapable of producing an adequate amount of insulin to control your blood sugar. And at that point, your blood sugar starts to climb, and that is type 2 diabetes. So when we're talking about these two conditions, which are very different, I guess I would start off with type 2 diabetes and say this: here's what we know. We know, based upon this recent article that I was just citing, that we believe that that the microbiome changes are actually associated with the pathogenesis of type 2 diabetes. And what we're seeing is that the loss of short-chain fatty acids, specifically butyrate, which is protective, which occurs when you have a diminished amount of these bacteria that I just mentioned, eubacteria, roseburia. When you lose eubacteria and roseburia and you don't have the production of butyrate, then you put yourself at risk for potentially the development of type 2 diabetes. Now, the entire pathogenesis of type 2 diabetes is not isolated to literally just this. We know that it has to do with intramyocellular fat. All right. But one of the key components, one of the key cogs, is butyrate. Because butyrate, this short chain fatty acid that I'm telling you is produced by the metabolism of fiber, helps to heal our gut. It actually goes straight to the colonocytes, is absorbed there, and it helps them to not only be healthy, but to repair themselves and to repair any increased intestinal permeability. You see an increase, for nerds like Cyrus, you see an increase in proteins like occludin. And occludin helps basically to seal the tight junctions between two cells in the lining of the intestine, in the lining of the colon. By sealing it, you are reducing intestinal permeability. When you reduce intestinal permeability, you reduce the release of bacterial endotoxin, also called lipopolysaccharide. So what's interesting about this lipopolysaccharide? Well, not done in humans, but in an animal model, if you take a mouse and you literally infuse bacterial endotoxin into that mouse, you do nothing else. You just infuse bacterial endotoxin. What happens to that mouse? the mouse becomes obese and develops type 2 diabetes. We know in humans that there are these changes that we've been talking about in the microbiome. And so the bottom line is that the different layers of evidence, whether it be in an animal model or in a human, we see that fiber is protective against type 2 diabetes. And we have human studies basically that show us these changes that occur in the gut microbiome that protect us from dysbiosis and the increased release of bacterial endotoxin. And now here I am saying that this bacterial endotoxin, if you were to infuse it into an animal, and we would expect similar results in a human, the infusion of bacterial endotoxin promotes obesity and type 2 diabetes, insulin resistance. So that's part of the pathogenesis of type 2 diabetes right there, and how it connects back to the gut. And then type 1 diabetes is very interesting because what they have discovered is that in the laboratory world, you can use mice that essentially are completely free of microbes, germ-free. All right, so they don't have a microbiome. And if you use a germ-free mouse, which is predisposed genetically to developing type 1 diabetes, that mouse actually will develop type 1 diabetes. Now, when they study this further, what they've showed is that if you transplant into that mouse the gut microbiome of someone who has bacteroides, which is, again, a protective bacteria, an anti-inflammatory bacteria, if you transplant that microbiome into that mouse that is predisposed to developing type 1 diabetes, with the proper microbiome, that mouse will not develop type 1 diabetes. So there have been a series of animal model-based studies that have basically demonstrated to us that alteration or damage to the gut microbiome, increased intestinal permeability, is associated with ultimately the development of type 1 diabetes, as well as type 2 diabetes, just a different pathogenesis.
Okay, now there's many people who actually believe that animal-based studies are problematic because they say, well, the research that's been done in animal studies can't necessarily be fully translated to human studies. And so the conclusions that you come up to from paying attention and participating in animal research is sort of strictly confined to animals and may or may not translate to human beings very well. So in the setting of the microbiome, is there a strong reason to believe that the pathogenesis you just described is translational to humans?
Well, we do know in both cases, both type 1 diabetes and type 2 diabetes, that there are alterations to the gut microbiome. Okay, so we know that to start with. Now, the problem is that if you study a population of people who have type 1 diabetes, they already have the condition, right? They already have the condition. So it's really hard to do human-based studies to demonstrate the ability to alter the risk of developing type 1 diabetes. We also know, when it comes to type 1 diabetes, that there are ways going back to early life, to your toddlers, to your newborns, that can reduce the likelihood of developing type 1 diabetes. So birth, like vaginal delivery birth as opposed to cesarean, reduces the risk of developing type 1 diabetes. Breastfeeding as opposed to bottle feeding reduces the risk of type 1 diabetes. Lack of exposure to antibiotics early in life reduces the likelihood of developing type 1 diabetes. Across the board, these things, which we know help to promote and foster an early, healthy gut microbiome, are protective against the development of type 1 diabetes. And that if you alter that natural development of a newborn's gut microbiome during this critical time where they're also developing their immune system, then you increase the likelihood that that person later in life will develop type 1 diabetes. So I feel that there are layers of evidence with type 1 diabetes. And then when it comes to type 2 diabetes, I would argue that the evidence is even stronger. Of course, yes, we have epidemiologic studies that show us that fiber is good for the improvement and reversal of insulin resistance. We have studies that show us that consistently. But when when we talk about this, I want to come back to the microbiome and say, well, what does the microbiome do? Because that's the argument that we're trying to make here. And they did a study where they took a group of young men who had metabolic syndrome and insulin resistance. They treated them with antibiotics, and then they transplanted into these young human men the microbiome of a lean donor, someone who did not have metabolic syndrome, did not have insulin resistance. And they transplanted this microbiome into these young men, and they see improvement in their insulin resistance markers. Now, that improvement was temporary. It didn't stick. And the reason why it didn't stick is it goes back to what Robbie was talking about with your diet being the number one determinant of your microbiome. If you take these guys who have metabolic syndrome and type 2 diabetes, insulin resistance, and you don't change their diet, and then you transplant the microbiome of someone who is lean and potentially has a totally different diet into them, those bacteria will survive for a period of time, and then over the course of weeks, they will die off. And they will be replaced by the old microbiome that this person had before because they haven't changed their diet. But if hypothetically you transplanted this lean donor microbiome into this person with obesity, metabolic syndrome, and insulin resistance, if you give them that lean donor microbiome and you change their diet specifically to a plant-based diet, I would fully expect sustained improvement and reversal of the insulin resistance of type 2 diabetes.
Could you hypothetically give those individuals or help them adopt a healthier diet, and then they would create their own healthy microbiome without having to transplant?
100%. That's exactly when you do the fecal transplant, you are creating a radical change that can be tracked instantaneously. And so it's really nice for research studies. It's proof of mechanism, right? It's proof of concept that by transferring literally just the microbiome to a new person, that you can alter their insulin resistance. That proves to you that the microbiome is relevant to the pathogenesis of insulin resistance, because that's the only thing that you changed. But in terms of changing your microbiome, 100%, it is not a requirement to have a fecal transplant. You can change your microbiome with your diet, and you just need to make that dietary change.
Okay, there you heard it, guys. Good news. You don't have to get a fecal transplant in order to improve your insulin sensitivity. You touched on an important subject here, which is fiber. Okay, everybody agrees fiber is good for you. Maybe there's some carnivore people that don't, but in general, most people are on board with consuming more fiber. Can you tell us, how does fiber help gut function, and how does it also affect blood glucose control?
Well, I think it comes back to these things that we're talking about, which is that the critical part to me of fiber is it is not in the mouth and then out the derriere like a torpedo, the way that we were raised to believe. You know, it's not this inert thing that literally has nothing other than it just kind of sweeps through. Fiber is metabolically active. Fiber is the food that feeds and nourishes the healthy microbes that live inside you. This is the reason why fiber, particularly soluble fiber and resistant starch, is referred to as prebiotic, because that feeds and energizes those microbes. And when you do that, they will chow down and get into a feeding frenzy, and then they will grow stronger. And you will alter the balance in your microbiome to favor good guys. You will get more of these bacteria that I'm talking about, eubacteria, Roseburia. You will get more of them, and they will become even more efficient at producing short-chain fatty acids. And when they make these short-chain fatty acids, they go to work. They go to work immediately. These short-chain fatty acids go to work, healing the colon, reversing intestinal permeability, lifting up the anti-inflammatory microbes, the good guys, directly suppressing the inflammatory microbes, directly suppressing things like salmonella and E. coli. All right, those are just the effects right there in the colon. But they have effects throughout the entire body. They interact with receptors called the G protein coupled receptors. And these G protein coupled receptors are completely relevant to protection against type 2 diabetes and insulin resistance. And that's part of the mechanism by which they work. They also communicate with our immune system. Type 1 diabetes is an autoimmune condition. You need immune dysregulation in order to develop type 1 diabetes. And the way that short-chain fatty acids protect you from type 1 diabetes is by interacting with your immune system, specifically activating T regulatory cells. T regulatory cells are the cells that basically get your immune system to chill, cool off, stop getting into a frenzy, stop going crazy, protect you from autoimmune disease like type 1 diabetes, but extending far beyond that, extending to the full milieu, the full litany of autoimmune diseases that exist. These short-chain fatty acids cross the blood-brain barrier. They affect neurologic function, your memory, protect us from Alzheimer's, Parkinson's disease. They affect your heart, cardiac function. They affect gene expression. They can alter the something called histone deacetylases. They can inhibit those. They're called HDACs for short. They can inhibit these HDACs, and by inhibiting these HDACs, they can protect you from colon cancer. So they have these effects throughout the entire body, and there's only one way to get them: consumption of fiber. Through the consumption of fiber, you can activate your microbiome and get the full benefit of the release of postbiotic short-chain fatty acids. And I'm going to tell you right now that there's all this hype about probiotics. People are starting to talk about prebiotics. And for the people who are listening to this program right now, I want you to know the entire point of prebiotics and probiotics is to get postbiotics. That's the entire point. So why not get to it and activate the health that comes from your gut microbiota with fiber?
Okay, so there's 1,000 directions that we could go from here. One of the things that I think is actually fascinating to go into a little bit of detail here about is that many people have pre-existing dysbiosis that can manifest itself in a number of different ways, whether it creates small intestinal bacterial overgrowth or SIBO, whether it's IBD, whether it's IBS, gastroparesis, gas, bloating, constipation, diarrhea, you name it, abdominal pain. So there's a lot of people who experience some combination of those symptoms. And then they get introduced to the idea of adopting a plant-based diet, but yet they're either hesitant to do it, or they find that when they do eat fiber-rich foods, that their symptoms sometimes get worse. So can you go into a little bit of detail here about, is that correct? And if that's happening, what could you do to alleviate that?
Sure. Let me start with this. Let's talk about dysbiosis. Some people will call it leaky gut. The correct medical term would be dysbiosis. It means damage or alteration of the balance within the gut microbiota. There's 3 parts that people need to know when it comes to dysbiosis. Alteration of the microbes, less good guys, more bad guys. Number 2, increase intestinal permeability. You are causing the breaking open of those tight junctions between the cells. And basically you are breaking down the barrier of the colon wall, which allows things to leak out. If you want to call it leaky gut, so be it. That's what's happening. And number 3, you have the increased release of bacterial endotoxin, which we already have talked about earlier in this episode, and how that plays a role in the development of obesity, type 2 diabetes. I'm going to tell you right now, it has a role in all inflammatory disorders, increased release of bacterial endotoxin. All right, those are the 3 parts. Fiber is the solution. Short-chain fatty acids are the solution. All 3 of those steps are reversed with short-chain fatty acids. All 3 of those steps. So the solution to these digestive issues is not to bail on fiber. The solution is fiber. And currently in the United States, the average person is getting about 15 to 18 grams of fiber per day. And only 3% of us are actually hitting the mark in terms of the amount of fiber that we should be consuming on a daily basis. We are wildly deficient in our fiber consumption. And that's how we develop these digestive diseases. So the person who has dysbiosis has damage to their gut microbiome. Their microbiome is not currently designed to help to unpack and process fiber. That's the challenge. You need a healthy microbiome to help you to actually unpack and process the fiber and get the health benefits that come from that. The paradox is the person who needs a plant-based diet the most is the one who is going to struggle the most to actually move towards a plant-based diet. And I would make an analogy to going to the gym. If my arm is in a cast and I take that cast off, I can't go and curl 40 pounds like I used to. I need to start off with a 2.5. I need to go so incredibly low and hit that sweet spot of what I'm actually capable of doing. And over the course of time, I will build up the strength necessary to get back to ripping off those 40 pound curls and looking like an absolute animal. I know you know what I'm talking about, Cyrus.
Right, you're doing 40-pound curls. You have to tell Nimai Delgado to look at.
Nimai's doing like 85-pound curls, bro. But
that's
anyway,
that's actually a brilliant analogy though, because we can all conceptualize what that means. Okay, you're injured. Try not to do things that are going to promote more injury, right? You got to start small and then build up over the course of time. And the same thing is happening inside of your gut microbiome. It's just not a necessarily mechanical, system, but it functions in a very similar way.
That's exactly right. And so you need to build your gut muscle back up, right? And so if you've been on an elimination diet, or you have not been consuming fiber, or you have dysbiosis and you have damaged your gut microbiome, then essentially you need to think of yourself as the person who you're not in shape. You're just not in shape right now, right? If you're not in shape, don't go and run a marathon without training for it. You got to build it up over the course of time. You got to build up that strength. And so the key is very simple: low and slow. Low and slow. That's how you roll when it comes to fiber. Start off super simple. So, we are all advocates for a plant-based diet because we know that this is the diet that is so clearly associated with improved health over the long haul. But the problem is that if you are not eating a plant-based diet, and particularly if you have one of these conditions that's associated with dysbiosis, you're going to have to ease your body into it, and you have to go at the pace that your body allows you to, and just ramp up over the course of time. Build that muscle back up.
All right, a final question for you, Dr. B. What is the number one obstacle that you see people run into when they adopt a plant-based diet, and how would you help them overcome this obstacle?
I think the number one concern or complaint is bloating, gas and bloating, and concern being that, does that indicate that there's inflammation or that you're incapable of processing that food or eating that diet? And so people will bail on it. And I understand why, because we have been taught over the last 20 years that if something causes a little bit of gas, bloating, abdominal discomfort, that must mean that we're intolerant and that we need to eliminate it from our diet. But the problem is that you hurt yourself in the process. When you restrict your diet, you restrict the diversity in your microbiome. And when you lower diversity in your microbiome, that's when disease shows up. So I am a believer in plant food in abundance and in diversity. And in order for us to accomplish that, we have to ease into this, and we have to make absolutely sure, this is one of my main things, we have to make absolutely sure that there is no constipation when you start to make this transition. Because if there is, you are going to struggle to be able to keep up with the fiber. The constipation is going to hold you back. And so the key is, from my perspective, I do this every single day in my clinic. You have to tackle the constipation first. Get that out of the way. And now it's time to start rolling and ramping up on a plant-based diet.
Okay, so we have to have a follow-up here. What exactly do you teach people to do to overcome the constipation?
There's a ton of options, right? So, I mean, obviously I'm a medical doctor, so I have an entire litany of things, but like we could start super simple. You can go for a walk. You can go for a walk after dinner. You could exercise. You can increase your water consumption. And for some people, they're going to need something to help to mobilize those bowel movements. And magnesium is a very safe way to consider doing that. There's clearly some people who are going to need medication. And, you know, if it turns out to be that, and that's frustrating for some people, just understand that from my perspective, if you get the constipation out of the way, it now opens up your diet. You can start to incorporate all these foods that you haven't been able to. And by doing that, you're going to start restoring a healthy gut microbiota. And when you restore that healthy gut microbiota, who knows what the possibilities are from a health perspective? You will only find out and know once you actually get there, and the constipation may go away.
This is brilliant. This is brilliant. Can we talk to you for like another hour? I mean, I don't have anywhere to be. I think, Dr. B, you have so much knowledge in your head, and you have such a simple way of explaining complex molecular biology to the average person to really simplify this. Today, we touched on a number of important topics. Number one, what is dysbiosis? Number two, what is the microbiome? Number three, what foods increase intestinal permeability? Number four, what are bacterial endotoxins and how are they implicated in the development of both type 1 and type 2 diabetes? Why is fiber such an important food? And why is it truly the most important component of your diet that can truly completely change not only your diabetes health, but also your chronic disease risk as a whole? Thank you so much for this fascinating information. You always deliver, and you deliver very cleanly and very sharply. We appreciate it. Now, tell our listeners how they can find out more about you and become a groupie. You have an upcoming book that's going to be released sometime soon. So please take a minute, brag about yourself, and tell people how they can find you on the internet.
All right. Super excited about this book. Like I just submitted the second version of it to my editor, and I cannot wait to share this with people. I think everyone's going to love it. If you've enjoyed this conversation even at all, then I think you're going to be blown away. And, you know, let me say this, like, because I'm excited about reading the Mastering Diabetes book. And just to kind of throw this out there for everyone listening at home, we can do a webinar and we can talk about all this stuff. And this is great. And this is a great way for us to communicate. Okay. Or we can make a documentary, and you guys would enjoy this 2-hour-long documentary and learn some really fascinating stuff. But you have to understand, this is for the listeners, you have to understand that the highest form of human communication that exists on the planet, and I think this will always be the truth, the highest form of communication that exists is a book. And the reason why is because I know you guys did, and I did too. I spent 6 months being at the top of my game, giving you every single thing that I had on a day in and day out basis to craft this book for you. All right. So I record a webinar, I show up, we talk for an hour. That's cool. But this book has been crafted. This is like my brain pulsating for 6 months, and out comes this book. And that's why I'm so excited about it, because I can't wait to share with people and see what they think about it. But nonetheless, if you want to hang with me right now and not wait for the book, which is probably coming out sometime in 2020, if you want to hang with me right now, come join me. Come to sign up for my email list at theguthealthmd.com. Come join me on Instagram at theguthealthmd. You can also find me on Facebook at theguthealthmd. And I love interacting with your people, and let's keep the conversation rolling.
Absolutely. This is fantastic. Thanks again for being here. You heard it directly from Dr. B. Go follow him, go stalk him on social media. Not only is he a smart guy, you know, when we do these podcasts and webinars together, but on social media, this guy is a machine. He's posting very, very, very important and evidence-based information at all times. So if you haven't already seen him, go check it out. I think you're really going to like it. So thanks again, Dr. B, and we will catch you next time.
Thank you. And I've been stalking you, Cyrus. I don't know if I'm supposed to say that on the air, but I just wanted to throw that out there.